All right, so what we're going to do here to start things off is we've got the area of a circle. And what we're first going to show is how you can relate the area of a circle to the area of a rectangle by the formula based on type. So we've got this. Put it up. Anyways, so we got this little.
Full attention, come on.
We've got this little display thingy up here on the board, and I'm just going to play with it a little bit, and I'm going to show you like how each thing kind of sort of works out. So what I'm going to do first is I'm going to take this right here is the circumference of the circle. I'm going to straighten it out. All right, and as you lay it all the way out, it shows this straight line, and you can represent that as the base. Okay, y'all see that? All right. So then I'm going to break it into these pieces, right? I'm going to rearrange these pieces to where they line up on that straight line. Okay? And so as you can see here, you now have the height of each of these little bitty triangular pieces. That can be represented with the radius of the circle at the beginning. And so that's where this R comes in, and that's the height of this rectangle. So what I'm going to do is I'm going to go ahead and fill in all these parts now, or I'm going to make the parts more and more and more. And as you see, it's filling in the rectangle now. And so now you've got pretty much a full rectangle, kind of like hypothetically. All right. So what this shows is you've got the radius times the base, or the height times the base, and that gives you 2 pi r squared. But if we come back to this beginning, like I had it, wrong one. Whatever. Like the beginning, like that, you don't have the top filled in like you want on a normal rectangle. So we're going to have to divide this area by 2. And then that's going to give you the area of a circle, which is pi r squared. So now Andrew's going to go ahead and relate that back to the area of a regular polygon. Unless you need to correct nothing.
The only thing that he's missing, like these gaps aren't filled in. So if you were to fill them in, right, you would then have a full rectangle. Okay. But since we only have half of this, what part of the rectangle are we considering? Half of the rectangle. So that's where really the formula here. So our base is 2 pi r, and our height is what? R. But I said we were only considering how much of the whole rectangle? Half. Because this is my B, here's my H, and then if I multiply all this out, I have 2 times pi r squared over 2. My 2's will cancel out, and then I'm left with pi r squared. That was the first way of coming up with the formula of a rectangle. Or not a rectangle, of a circle.
Okay, let us sink it in.
Yep. Don't need to write that any bigger.
You have a question, Sarah?
No, I was going to explain to Maddie.
No, I got it. No, I'm going to.
No, I'll rewrite.
Oh, is that okay? Yeah. It's just he ready to.
What are your thoughts, Naya?
Oh no, I was asking Hannah.
I'm just going to rewrite this on the side. That way we can leave it on the board. The other way we're going to do it, and the reason we wanted to go after the regular polygon group is because we want to compare it back to, or we're going to try and derive the area of a circle formula from the area of a regular polygon. I just have to rewrite this real quick. We had this a second ago. All right, so for going back to the last last group, what was the area of the formula for a regular polygon that we came up with? Equals.
Bottom little a times perimeter. Are you saying for a regular polygon?
Mm-hmm.
Oh yeah, and then divide by 2.
Yeah, we're gonna leave it as just as 1/2 for now. A and then perimeter. Okay. I'm just gonna draw this out to the side. We were trying to come up with a way of how to like have for something for you guys to do, but it's a little bit ridiculous because the pieces get way smaller and smaller. So we're just gonna go with a. Ignore my really bad hexagon, but imagine that's a perfect hexagon. All right, we're going to do exactly as the last group did. Here's my apothegm, and here's my triangle that we created there. So let me ask this. Is we increase the number of sides here, so we'll just leave this as n, and here how many sides do we have total? 6. What happens to that length if I increase it from 6 to 7? What happens to this length right here? So, I don't know. We'll have that as a side. All right. And what I'm also going to do is rewrite this P as n for the number of sides times the length of that side, right? And that's how we also get the perimeter around the polygon. So as I said, as you increase the number of sides, S eventually does what? It gets smaller. But keep in mind what also happens to this A right here.
Okay, so look at this. Each time that you're decreasing the side of this, all right, what the apothegm does is it bisects this side. Y'all see that? So whenever it cuts that side in half, it's going to be moving closer and closer and closer to this point. So as this right here is moving closer and closer and closer to that angle right there, what is happening to this segment? It's length.
It has to get longer. So I'm just going to draw one. I don't know, it's really bad. But that's really bad. All right. The idea being, as the number of sides increases, what you end up coming to is these will eventually meet up to an individual point. All right. And then if we end up meeting to an individual point all the way around, what would be our perimeter then? As all those sides come up to a point, what do you now have? You end up with a circle. So what is our new perimeter then? The circumference of the circle. So this, I'm going to rewrite this as 2 pi r. As this A now gets longer, because it has to meet up to the edge of that circle, what does that eventually become? The radius. So if I were to, again, do the same thing, I have 1/2. I'm just going to rewrite it so it's all close together. And that's the other way of getting the area of a circle from a regular polygon. It's a little bit hard to see because you have to kind of picture the sides getting infinitely smaller up to an individual point, but as the sides get smaller, the A eventually extends out to become the radius.
That's why I really like this, because what you can do is you can see as you have more and more parts that went into the circle, what happens to each part.
This is what I'm talking about, the sides. As you increase the sides, they eventually just become one point. And if you think of a circle, it's kind of, because this is how I was thinking of it in my head, is how many points do you have on this hexagon? Really? 6. How many points do you have on a circle? Infinite amount. So that's what I'm saying is it increases infinitely. The sides become infinitely smaller up to a point, and then you have an infinite amount of points going around the circle. Sorry we didn't have anything for you guys to cut out and play with, but this is one of the tough ones to have to try and...
Does this make sense?
Does anybody have any questions about it? Because we could write what Jerry had us write. And
Yeah, me too. I like that.
I mean, I can. I have it figured